Section 9.3, Solving Equations that are Quadratic in Form. In this section, every problem we see is not going to look quadratic, but once we manipulate it, we'll see that we end up with a quadratic equation, so we can solve by using the 4 techniques from the previous sections. So number 1, solve. This is a rational equation. Rational means fractions. And how do we solve fractional equations? We find the LCD. So looking at our denominators, we have an x minus 3, and a 6. So our LCD would be the x minus 3, and the 6. There's nothing in common. So we'll need to multiply everything by 6x and x minus 3. So when we multiply the first fraction, 1 over x, by the LCD, the x's will cancel, and I'll be left with the 1 times the 6 times the x minus 3. Plus, what does a 2 get multiplied by? Well, it had the x minus 3 in the denominator, so that will cancel. So it'll just get multiplied by the 6 and the x. Equals, what's a 5 going to get multiplied by? Well, it had the 6. It didn't have the x or the x minus 3, so only the 6 is going to cancel, and we're left with the 5 times the x minus 3. So 1 times 6 is 6, and then we'll distribute the 6. We get 6x minus 18. 2 times 6x is 12x, equaling, distributing the 5x. 5x times x is 5x squared, and 5x times 3 is a negative 15x. So now we see that we do have a quadratic equation because of that square right there. So I'll combine like terms and bring everything over to the other side. I'll take things to the right hand side because the 5 is already positive. So combine like terms, 6x plus 12x, I'm going to get an 18x. I still have a minus 18, equaling a 5x squared minus 15x. So I'll subtract the 18x and bring it over to the right hand side and put it with its like term. I'll add over the 18, and therefore I will have everything over on one side with a 0 on the left hand side. So 0 is going to equal 5x squared minus 33x plus 18. At this point, you can decide if you want to do the quadratic formula. This one actually is factorable, so I'm going to let you either do the quadratic formula QF or factor it, and your final answers would be x equaling 3/5 and 6. So I'm not going to show the quadratic formula in this section or the factoring part of it, but either way you should get to those answers of x equaling 3/5 and 6. Now there's one thing we have to be careful of. When we have a fraction, we never want our denominator to become 0. So looking at our denominators, we would not want x to be 0 or 3, and those are the only two answers we don't want. The answers I got were 3/5 and 6. So I should be able to keep those answers because they did not make my denominator 0. Number 2, we have 2 minus x to the negative 1 minus 15x to the negative 2 equaling 0. Well, way back when we talked about negative exponents, that what do? They move things. So the 2 stays as is. X to the negative 1 can be rewritten as 1 over x minus 15 is positive, so it doesn't move, but the x squared is going to go to the bottom, and we still equaling it to 0. So remember, negative exponents move things up and down. So x to the negative 1 moves down, x to the negative 2 moves down and becomes a positive exponent. So now we'll start off the same way. We need to find the LCD. The LCD would be x squared because x squared is x times x. So that other denominator is already with the x squared. So I'll need to multiply everything by an x squared. When I do so, 2 times x squared is 2x squared. X squared times 1 but divided by x is an x, so I get a minus x. And x squared times 15 but divided by x squared is just a minus 15, equaling 0. So at this point, you can either use a quadratic formula, or this one is actually factorable. So you can decide what you want to do. Do you want to do the quadratic formula, or do you want to factor? Either way, you're going to come up with answers, x equaling negative 5/2 and 3. So I would definitely use the quadratic formula or factor, and make sure you can get the answers of negative 5/2 and 3. We can also use something called a U substitution. When we are trying to make an equation a little bit nicer looking, there are a couple of different hints that I'm going to give to you. So number 1, you want to rewrite the equation so that it is in the form with a u. For example, you're going to want to write it as au squared plus bu plus c equaling 0. Now where is this u coming from? Well, there's only two possibilities in 116 that we're going to need to use the u. The first hint is if you have parentheses, you let u equal what's inside the parentheses. If you have like a crazy variable with crazy powers, those kind of things, you're going to let u equal the middle variable. And if you have powers that don't look quadratic, once you let u equal the middle variable and square both sides, you hopefully will get au squared plus bu plus c equaling 0. Therefore, you'll have a quadratic equation. So you'll solve, but you're going to be solving for u at that point. Once you solve for u, then you need to go back and resubstitute for what you said u was. You either said u was what was inside parentheses, or you said let u equal the middle variable. And at that point, you have to solve for the original variable. And then make sure you check your solutions. So number 1, 3a minus 2 squared plus 2 parentheses 3a minus 2 equals 3. You actually have an old technique. The old technique is to take 3a minus 2, multiply by 3a minus 2, distribute the 2, combine like terms, and all those good things. You could still follow that technique. But if we look at what our hint told us to, it said let u equal what's inside parentheses. So I'm going to let u equal 3a minus 2. If I do so, I'm just going to end up with a u squared plus 2u equals 3. And that looks much better to solve. I'll subtract over the 3, so u squared plus 2u minus 3 equals 0. It is factorable, so I'm going to factor into u plus 3 times u minus 1 equaling 0. Set each factor equal to 0, so I get u equaling negative 3, or u is going to equal 1. Now, don't circle that answer yet, because you solved for u, but our original variable was a. So we said u was 3a minus 2. So I need to resubstitute and put 3a minus 2 back in and solve for a. So it's going to look like 3a minus 2 equaling negative 3, or 3a minus 2 would equal positive 1. So I'm going to add over the 2, so 3a equals negative 1, divide by 3, so a is going to equal a negative 1/3. On the other equation, I'm going to add over the 2, so 3a is going to equal 3. I'll divide by 3, so a is going to equal 1. So my two answers are negative 1/3 and 1. If you want to go the old technique, you could certainly do so. It's just going to take you a lot longer. Number 2. 3 parentheses x minus 5 quantity squared plus 14 parentheses x minus 5 equals 0. Again, the old technique was to multiply all that out. The new technique was to say what's in parentheses. So we're going to let u equal x minus 5. If we do so, we get 3u squared plus 14u minus 5 equals 0. Students always ask me, what if they're not the same? Well, in 116, they will be the same. So you're going to let u equal what's inside the parentheses, and that should be the same thing. Now at this point, you can either use AC method, or you could use the quadratic formula. If you do the AC method, you're going to get 3u minus 1 times u plus 5 equaling 0. We'll set each factor equal to 0, so u is going to equal 1/3, or u is going to equal negative 5. So if you use the quadratic formula, don't put x equals. Make sure you put u equals. Then we go back and resubstitute for what we said u was. U was x minus 5, so I need to go back and resubstitute and put an x minus 5 into both of those. So x minus 5 would equal 1/3, or x minus 5 would equal negative 5. So I'm going to add over the 5, and 5 plus 1/3 is just 5 1/3. And when I add over the 5, negative 5 plus 5 is just 0. So I get two answers, x equaling 0 and x equaling 5 1/3. Both of these answers should check, so if you have time, I would say check. Number 3, x to the 4th plus 2x squared minus 8 equals 0. So at this point, we don't have parentheses anymore. We have, in a sense, some crazy powers. Powers bigger than just an x squared. So what did our directions tell us to do? They said let u equal the middle variable. Our middle variable is just x squared. Now, what do we do next? we're going to square both sides. Square the left and square the right. So u squared is going to equal x squared squared. So what does that make it turn into? U squared is x to the fourth. So do you now see that x to the fourth becomes u squared plus 2, x squared was u, so 2u minus 8 equals 0. So I've changed this into a quadratic by letting u equal the middle variable and then squaring both sides. So now we're factors of negative 8 that up to positive 2 or positive 4 and negative 2. So it's going to factor into u plus 4 and u minus 2 equaling 0. Then we can set each one equal to 0. So I get u equaling negative 4, or u is going to equal 2. But remember, what did we say u was? We said u was x squared. So now an x squared needs to be replaced back into where u was. So we're going to end up with x squared equals negative 4, or x squared is going to equal 2. This is the square root property, so we'll take the square root of the left and the square root of the right, not forgetting plus or minus. And what's the square root of negative 4? Well, that's 2i. And we'll take the square root of the left and the square root of the right, not forgetting plus or minus, and the square root of 2 we'll leave as the square root of 2. So I have 4 answers: 2i, negative 2i, square root of 2, and negative square root of 2. We ended up with 4 answers because our degree was 4. Number 4, 9x to the fourth minus 49 equals 0. What if we don't have a middle variable? Well, let's think about factoring. This does look like a difference of squares. 9 comes from 3, and 49 comes from 7. Then what do we got to do? Well, normally we put an x and an x, right, with a plus and a minus. The problem is x times x is not x to the fourth. But x squared times x squared is x to the fourth, because when we multiply, we add powers. So this one is just factorable. 9x to the fourth minus 49 does factor into 3x squared plus 7 and 3x squared minus 7. So then we'll take each factor and set it equal to 0. So I'm just going to come up here. So 3x squared plus 7 would equal 0, or 3x squared minus 7 would equal 0. So then I'll subtract over the 7, so 3x squared is going to equal negative 7. Take the square root of both sides after I divide by 3. Don't take the square root yet, because you got to get the x squared by itself. So x squared equals negative 7/3. Take the square root of the left and the square root of the right, not forgetting plus or minus. There's an I, because you're going to have a negative underneath the square root. So an I comes out, the square root of 7 stays as is, and the square root of 3 stays as is. So now we have a radical left in the denominator, which we're not allowed to do. So we have to rationalize. We multiply top and bottom by what? The square root of 3. So x is going to equal plus or minus square root of 7 times the square root of 3 is the square root of 21. I stays on the outside, and the square root of 3 times the square root of 3 is the square root of 9, which is back to 3. So there's 2 answers there. We'll solve the other equation. 3x squared minus 7 equals 0. So I'll add over the 7. So 3x squared equals 7. I'll then divide by 3 to get the square by itself. So x squared equals 7/3. Then I'll need to take the square root of both sides, not forgetting plus or minus. So I get x equaling plus or minus the square root of 7 over the square root of 3. We're not allowed to leave a radical in the denominator, so I'll multiply top and bottom by the square root of 3. When I do so, I get x equaling plus or minus the square root of 7 times the square root of 3 is the square root of 21. Square root of 3 times the square root of 3 is the square root of 9, which is back to 3. So I do have 4 answers: square root of 21i over 3, negative square root of 21i over 3, positive square root of 21 over 3, and negative square root of 21 over 3. So let's look back at 3 real quick. What if we didn't want to do the u substitution? Could we just factor number 3 instead, kind of like we did on number 4? Well, there are factors of negative 8 that add up to 2. Sure, there's x plus 4 and x minus 2. The problem is x times x is not x to the fourth. But x squared times x squared is x to the fourth, because when we multiply we add powers. And if we tested outer and inner, that would give me the 2x squared. So if you don't want to do a u substitution, you could still factor. You just got to make sure you use the right power. And the way to do that is to look at that middle variable. Number 5. x minus 6 times the square root of x plus 8 equals 0. It is a trinomial. There are 3 terms. It does have some crazy powers in a sense, so we could start trying that hint that said let u equal the middle variable. If I let u equal the middle variable, we're going to say let u equal the square root of x. So then what should we do? Well, we should square the left and square the right because we want to make sure we get the middle variable becoming our first variable by squaring both sides. So we get u squared and the square root of x squared. Well, u squared is u squared, and the square root of x squared just turns out to be x, and that is my first variable. So u squared is now going to be x. So my equation becomes u squared minus 6u plus 8 equals 0. In 116, if you square the middle variable, you should get that first variable, and that's why it turns into be a u substitution form. Factors of 8 up to -6 are -4 and -2, so this is going to factor into u minus 4 and u minus 2. Setting each factor equal to 0, I get u equaling 4, and u is going to equal 2. But we didn't have u from the beginning, we had x, so what did we say u was? U was the square root of x. So the square root of x has to be equal to 4, or the square root of x has to equal 2. Now, how do we get rid of the square root? We square both sides, not square rooting, we square both sides. So when I square the left and I square the right, the square and the square root cancel, so I get x equaling, and 4 squared is 16. On the other side, when I square the left and square the right, the square and the square root cancel, and I get x equaling 4. Now, you want to star these because you must check your answers. Why do you need to check your answers? Because we had square roots from the very beginning. See how we had an x minus 6 square root of x plus 8 equaling 0? With square roots, sometimes answers don't always work. So we need to check both of these answers. So I'm going to check the 16. So when I check x equaling 16, I get 16 minus 6 square root of 16 plus 8 is supposed to equal 0. I'm going to put a question mark because I'm not sure. Well, the square root of 16 is 4, and 4 times 6 is 24. So I get 16 minus 24 plus 8. Does that equal 0? Yes. So x equaling 16 works, so I'll keep x equaling 16. But now let's check x equaling 4. So now when I check this one, I'm going to plug in a 4. So 4 minus 6 square root of 4 plus 8 equals 0. Well, square root of 4 is 2. 2 times 6 is 12. So I get 4 minus 12 plus 8. Does that equal 0? Yes, because 4 minus 12 is a -8, and -8 plus 8 is 0. So for this example, both answers worked. Sometimes one will, sometimes one answer won't work, sometimes they both work, sometimes they both don't work. So definitely need to just keep checking your answers when you have square roots and fractions from the beginning. So number 6. T minus 3 square root of t minus 10 equals 0. We'll start off the same way. We're going to say let u equal the square root of t, the middle variable. Then what do we need to do? We need to square the left and square the right, so hopefully we get the first variable. So when I square u squared, I just get u squared. When I square root and square the t, I get t. So u squared does equal t, so then my t is going to become u squared. So I get u squared minus 3u minus 10 equals 0. Is it factorable? Are the factors of -10 that to -3? Sure, -5 and 2. So this is going to factor into u minus 5 times u plus 2 equaling 0. Set each factor equal to 0, so I'm going to get u equaling 5, and u is going to equal -2. Then I substitute back for what u was. Well, u was the square root of t. So I get the square root of t equals 5, and the square root of t would equal -2. Then I'll square both sides to get rid of the square root. When I do so, I get t equaling 25. When I square the left and the right on the other problem, I get t equaling 4. So right now I have t equaling 25 and t equaling 4. I'm going to star these because you better check your answers because you had square roots from the beginning. So I'm going to check 25. So if I check t being 25, I get 25 minus 3 times the square root of 25 minus 10 is supposed to equal 0. So 25 minus, well, square root of 25 is 5, 5 times 3 is 15, and 25 minus 15 minus 10 does equal 0. So t equaling 25 is okay. Now let's check t equaling 4. So if I want to check t equaling 4, I'll plug in t being 4. So I get 4 minus 3 square root of 4 minus 10 is supposed to equal 0. Well, 4 minus, square root of 4 is 2, 2 times 3 is 6, so minus 6 minus 10, that does not equal 0. So t equaling 4 is extraneous. So the only answer I do have is t equaling 25. Number 7. 3x to the 2/3 minus 4x to the 1/3 minus 4 equaling 0. Again, we have some crazy powers. So how do we start off? We say let u equal the middle variable. So we're going to let u equal x to the 1/3. Then what do? We square both sides, hoping we get the first variable. So u squared is just going to be u squared. When I take x to the 1/3 and I square it, I multiply powers. So I end up with x to the 2 times 1 is 2, 3 times 1 is 3, so I get x to the 2/3. Did I end up with my first variable? Yes, I did. So u squared is x to the 2/3, and u is x to the 1/3. So my equation is going to turn out to be a 3u squared minus 4u minus 4 equaling 0. So at this point, you could either use the AC method or you could use a quadratic formula. I'm going to skip to the factors using the AC method. You might want to make sure you can do this. So 3u plus 2 times u minus 2 is going to equal 0. So that's how that factors. So try the AC method or try the quadratic formula. If you do the quadratic formula, you're going to get u equaling negative 2/3, or u is going to equal 2. Now remember, what did we say u was? Well, u was x to the 1/3, so I need to put a u being x to the 1/3 back in. So x to the 1/3 is going to equal negative 2/3, and x to the 1/3 is going to equal 2. So how do we get rid of a 1/3 power? Well, we take it to the third power. So we're going to raise both sides to the third power. So 3 times 1/3 is just 1, so I just get an x. Now negative 2/3 raised to the third power is just negative 2 times negative 2 times negative 2, which is negative 8, and 3 times 3 times 3, which is 27. So I get x to the negative 8 over 27. On the other equation, I'm going to again take it to the third power. When I take x to the 1/3 raised to the third power, I just get x. And 2 cubed is 2 times 2 times 2, which is 8. We should check these answers, but if you look at the index is a 3, which means it's a cubed root, so we won't have to worry about any extraneous solutions. So both answers should work, of x equaling negative 8 over 27 and positive 8.